Hey guys, happy Easter. My name is Daniel. I'm here from the Challenger Learning Center. I'm here with another Easter activity that you guys can do when you're at home using items that you have at your house as well. It's another engineering activity. It's investigating how well we can balance certain things. And our objects here are very simple. We have some Peeps. You can use regular marshmallows as well. The bigger would be most likely better. But we have Peeps here because it's Easter time, right? We have some skewers here. We also have some toothpicks, okay? That's all you would need to do this experiment. So first step, I want you guys to grab some Peeps. I have a couple here. I have about 5 here. We're actually going to use a couple more than this, but we're going to do 5 at first here. And we're going to put them on either end. Well, we're going to put 3 on one skewer. We're going to put 2 on either end and then 1 in the very middle and see how well we can balance this out. Okay, so watch this carefully. Here we go. Okay, here's our number 1. Beware, it is a little sticky. So, but it's all part of the fun, right? Oh no, I lost a Peep. I'll get that later. And actually, I'm going to flip this around. This is number 2. And let me get number 3 down here. Got a little pine straw on it, but that's okay. And we're going to put number 3 on the end like this, okay? And I want you to see how well we can balance these 3 Peeps out by just putting your fingers under this middle one. You see how pretty much level it is. If it were more on the end, you can see if I move it over a little bit and I put my fingers under there, I can't really balance it very well, okay? It's not very level. And the same thing if it were too far on this end. So you want this middle Peep to be, or the middle marshmallow to be pretty much in the middle as much as possible. That way it's about as level as that. And where my fingers are, that is going to be called our balance point, okay? Our balance point is very important to, to tell how easily we can balance things out, okay? So that is our balance point, okay? And this is also related to the center of mass. We're actually going to get to that in just a minute. I'm sure you may have heard about that, but the center of mass is very important by telling how unstable or maybe stable a system or an object might be in relation to the balance point, okay? Pretty much saying how, well, if it's stable, that means it's able to be balanced easier. If it's unstable, it's harder to balance, okay? So that's what that means, and I'm sure you'll learn more about the center of mass as you go more in school, but we are going to investigate that with this experiment, okay? So that is our first step. I want to add on some more marshmallows or some more chicks here and see if that changes our ease of balance and see how if it makes it easier to balance out this system here. Okay, I'm going to add 2 more or 2 toothpicks on the end chicks like that. Okay, I'm going to kind of push them through like this. And then we're going to add on 2 more marshmallows here and then add 1 more skewer in between those without a middle one, okay? So I'm going to have a skewer. I'm going to go and put them through 2 more marshmallow chicks like that. And then we're going to put these chicks on the bottom of these 3, okay? So here's my other skewer with the 2 chicks, and then we're going to put these on the bottom like this. We're going to put the toothpick through the bottom chicks like this, okay? So there you go. Okay, so this is our system, if you will, our collection of objects that make an entire, I don't know, system of marshmallows, toothpicks, and skewers, okay? Now, I'm going to put my finger here, again, our balance point, underneath this middle chick. It feels more secure, it feels easier to balance, okay? And I want to show you why, okay? This is more stable, if you will. It's easier to balance versus just the 1 skewer with the 3 marshmallows that we had before. Let's investigate this. So I'm going to set this aside. Just remember to move this right here. And I actually have this drawn out over here on my handy dandy clipboard. You can see it right here. Each circle represents a marshmallow, or in this case, a Peep, okay? And then here's my skewer, my top skewer, bottom skewer, and my 2 toothpicks, okay? Now, watch again. I'm going to show you this. Remember, my balance point was where my fingers go, right? Now, look at this. It's pretty horizontal, right? So it's not tilted at all, which is good. So that shows that it's balanced pretty well. I'm going to, on this diagram, I'm going to mark an X where my finger goes. And I want you guys to do this as well when you investigate this at home, using whatever items you have at the house. So mark an X where your fingers go. So this is my middle marshmallow, or my middle peep in this case. Put an X there where your fingers go, okay? And then draw a dotted line straight down from where your fingers were. Since it was horizontal, okay, it wasn't tilted or whatever, I can keep it level and draw my dotted line straight down from my X, or where my fingers were. Now keep in mind, if you weren't exactly balanced and it were tilted a little bit like this, you would have your dotted line be a little angled differently than what I have here. Okay, so make sure to angle your diagram based on what you see here with your marshmallows and your skewers and your toothpicks. Okay, so make sure that this is a duplicate of what you see here. Okay, so that is test number 1. We have 2 other places to test out where the balance is. Test number 2, I want you to put your fingers underneath the toothpick on either side. Okay, that looks pretty vertical for the most part. Let's see. It's a little angled this way. Let's check on the other side. Oh no, it's falling apart. Bear with me. Sometimes this happens, so just realign everything. And let's go and retest here. Engineering is all about problem solving and testing, so make sure that you keep that in mind as you work on this. So that actually made it more vertical. See, it's all vertical. And then the other side, let's try this out. That looks pretty vertical as well. Okay, so we can draw our 2 X's again. Okay, the whole point of doing this is showing, or trying to find out where the center of mass is. And that's the main goal of doing this, by the way. So we're going to draw our 2 X's where our fingers went underneath the toothpicks. So we put our fingers there under this toothpick and under this toothpick right here. Okay, and since it was even and pretty vertical, we can draw our line straight down. Well, actually, straight down from where our fingers went. Okay, and the same thing on this side. We had our fingers here, and we're going to draw our line straight down from where our fingers were. Okay, so there's step 2. Now, step 3 is we're going to put our fingers below these 2 corner marshmallows. Okay, you want to see where you want to pick the marshmallows that are further away from this middle initial marshmallow. Okay, so we're going to choose these 2 and see how well we can balance there. Okay, so we have, look at this. Okay, it's a little angled. It's not vertical like it was with the toothpick. When we put our fingers under the toothpick, it's a little angled this way, right? And then this side, let's see how this side is. It's a little angled this way. Okay, so our vertical line is going to go like this on our diagram. Okay, and then it's going to go like this through our diagram. So it's going to be, if you envision an imaginary dotted line, it's going to kind of go just beneath this middle chick, and it's going to kind of go through this one, since our imaginary vertical line straight down from our fingers goes straight through this chick. And it should be the same with this one. It should go right below this middle chick and straight through this corner chick. Do you guys see that? So that's our imaginary dotted line. So let's draw that on our diagram here. So our fingers went here. Actually, no, they went, let's see, yeah. Actually, our fingers went right here. Ignore this one. Fingers went right here. Okay. And we're going to draw our dotted line through this corner chick because it was a little angled. So we're going to angle our diagram to be like it was that we saw in real life. Okay. And we're going to draw our line straight through this marshmallow like that. Okay. It's going to be the same with this one. We're going to draw our dotted line straight through this corner chick. Okay. You guys see that? Okay, I'm trying to go nice and slow for you guys in case this is your first time seeing this. Now the key here is where these lines intersect, meaning that where they all meet up and they cross through at the same point. This line, or this part, this place, is called your center of mass. Okay, like I said before, the center of mass shows how stable or unstable your system or your object is. Meaning, if it's more stable, it's easier to balance. If it's unstable, it's harder to balance. Okay, now in general, as a rule of thumb, and I'm sure you'll learn this more in school, if the center of mass, which is right here, if that is below your balancing point or your balance point, where this X is, okay, in this case, since the center of mass is below your balance point, your system or your object is more stable, meaning it's easier to balance. If this center of mass were above your balance point, or this X, if it were up here, that would mean the system would generally be more unstable. If the center of mass is above the balance point, it's more unstable and therefore harder to balance. Okay, but since it's below, it's more stable, meaning it's easier to balance, and that's what we showed here, that compared to just the skewer with the 3 chicks on it, just the one skewer, this one is technically easier to balance, and therefore it's more stable. Does that make sense? I hope it does, because I really worked to try to take you guys nice and slow through this. It can be a complicated thing to kind of wrap your head around, but once you see it, both here and on here, hopefully it will start to click, okay? So let's take this one step further, and let's add on some more marshmallows to this middle chick and see what happens. I'm going to take 2 more marshmallows here, and I'm going to kind of cluster them around this middle chick. I'm going to take 2 marshmallows, kind of make some, kind of make some antenna on this one chick. I'm going to put this through. Sometimes these toothpicks kind of fall through, they don't really hold as well. And I'm going to kind of cluster these 2 marshmallows around this middle one and see how that affects our ability to balance out our system, our object here. Okay, so make sure these toothpicks are right through. Okay, so it feels a little bit wobbly to me just by initially holding this compared to the system that we had, or how we had it without the 2 pink chicks. It seems a little bit more wobbly in a sense, but we're going to investigate if that is the case and why. Okay, and I want you guys to try this at home as well when you work with this. So I have another diagram here. So we already finished up this one. I have another diagram here that shows this that we just made with the 2 additional chicks here. Now, I again put my fingers there underneath that middle chick, and let's take a look at this one more time. I put my fingers there, and it looks pretty horizontal, so I don't have to tilt my paper or whatever to line up with this, so I can just leave the paper as is, and we're going to draw our vertical line straight down from where my finger was, the balance point, okay, like that. And we're again going to put our fingers on the toothpicks and then underneath these 2 corner chicks and see where our center of mass is now. Okay, so I'm going to put my fingers here. Ooh, it's definitely tilted. Look at that. So if you imagine a dotted line straight down from my fingers, it would kind of go through this middle chick, right? If it goes straight down to the ground, it would kind of go through this middle chick. Let's see if it is the same over here too. Yeah, look at that. Both ends, an imaginary line straight down from my fingers, goes straight through this middle chick. So let's draw that on here. So we're going to put we have our fingers underneath that toothpick and also this one. Remember, it's a little tilted. It wasn't straight vertical. So our dotted line is going to go through this middle chick from our fingers. Kind of like that. And then underneath this toothpick, same thing. Okay, you guys see that? Now we're going to put our fingers right here underneath the 2 corner marshmallows and see where our imaginary dotted line would go then. Ooh, it's even more tilted. Look at that. So straight through, kind of straight through this middle chick again. And let's see if this is the same for, ooh dear. Sorry, my apologies. Let me put this back together. Let's check out this one. Yeah, same idea. Imaginary dotted line straight through this chick. Okay, so let's do this. Here are my 2 X's for where my fingers went through this middle chick. And same thing for this end. We're going to take it through from here. through the middle check. Okay? Now, this initial line, we can actually extend this dotted line up, and again, where these lines intersect, or where they all meet up, that is where our center of mass is. Look where it is. It's about right in here. And look, it's right above, it's actually above where our balancing point or our balance point is, which is right here at this X. Remember what I said, if it's above the balance point, in general, it would be an unstable object or system, meaning that it's harder to balance. And that's what I found when I first tried this with you guys. So, some extensions to this. Okay, so we know how the center of mass relates to how well we can balance it. Some extensions for you guys: try different shapes, try different numbers of marshmallows as well. Just take, I would say, take these toothpicks off and just have the initial 3 chicks that we had, and pile on as many marshmallows as you can on this middle one, and see if you can still balance it. See how it changes everything. Okay, I hope you guys had fun with this and enjoyed this. Try this at home and let us know. Okay, and I will see you guys later. Bye. Hey guys, some final project ideas for you to further investigate where your center of mass is using different shapes. Remember, we used Peeps and skewers and toothpicks before to make a rectangle, but we can change it up just a little bit, and we can make, using, this is just using skewers and Peeps, using either a square or even a triangle. Okay, I want you guys to investigate using what you have around the house and trying different shapes, and see where the center of mass might change based on what shape you make. Like we did before, make sure to draw it out and find out where your points, where your lines intersect, like we did before, and find out where the center of mass is on these shapes and even more that you can make. Use what you have at home, keep us updated, and I'm anxious to see what you guys find.